Hi! This time I'll show you how to remove overlapping parts of objects using Boolean and Voxel Merge. In this tutorial, I introduce 3 different workflows and also cover mesh adjustment for each method. I've added chapters, so feel free to use them if helpful. I hope this is helpful. First, the setup is prepared. We will proceed with smooth shading turned off. The default quad sphere has a dense mesh, so another object is used to make the explanation clearer. Also, to regularly check the mesh state, the wireframe display is frequently toggled while working. Tap Delete to remove the quad sphere. This tutorial uses a UV sphere. Tap Clone to duplicate the UV sphere. There are now 2 UV spheres. The duplicated UV sphere is currently selected. Switch to Gizmo. The UV sphere is moved to the right using the red arrow. The setup is now complete and the main process begins. First, we start by using Boolean in a simple way. I'll modify the shape using overlapping geometry. Hide the left UV sphere. Select both UV spheres. Tap Boolean. A new window appears. Tap Boolean. The overlapping parts have been removed. Using Boolean makes it easy to perform this kind of operation. We will enable smooth shading. Enabling smooth shading allows you to see the distortions in the shape. This happens because using Boolean has caused the mesh at overlapping boundaries to distort. If you don't use smooth shading, it's not an issue. But since smooth shading simulates a smooth surface, adjusting the mesh is necessary for a clean result. This is just my approach, and I'll continue with the mesh adjustments. I'll proceed with smooth shading turned off. Although adjustments can be made in this state, to make the explanation clearer, I will first reset the gizmo to the center of the object. Open the pivot window and tap Auto. The gizmo has been reset to the center of the object. Enable Snap and set it to 90 degrees. Move the pen along the green line to the right and rotate the object 90 degrees to the right. This positions the cut section at the front, making it easier to work on. Since the object is offset from the world center, the origin of the entire scene, we will adjust it as well. Tap Move Origin to reset the position. With the position adjusted, mesh adjustments should now be easier. First, check the object's face group. The face group is all blue, so we will add a new face group to the cut surface. Separating the face group makes it easier to accurately define the shape during mesh adjustments, increasing the chance of clean remeshing. Tap Normal on the top bar. You can easily add a face group here, but check Preview to see how it is generated. By default, angle is 45.0 degrees, but lowering it will divide the face group into smaller sections. A new face group has been added to the cut surface. Once confirmed, tap Normal. Next, switch to Quad Remesher. Enable the face group option so that Quad Remesher recognizes it. Set symmetry if needed. Enable the axes you want for symmetrical remeshing. Since this is a simple shape, we enable the X and Y axes this time. The method is set to World. Turning on Grid helps, as the intersection of green and red lines marks the world center, which serves as the reference. The reason the object was reset to the center earlier was to align it with this reference. If you want symmetry relative to the object rather than the world, change Method to Local to switch to Object-Based Symmetry. However, the axes will also change, so adjust them according to the reference lines. For this object, the Y and Z axes are the correct symmetry axes. Double tap with 2 fingers to reset the object to the center of the world. We will continue working from here. With symmetry set, I enable symmetry and remesh the object. This time, I remesh the object with roughly the same number of vertices. The boundaries of the cut part have been cleanly remeshed. Since Quad Remesher is automatic, it may not always give the expected result. I appreciate your understanding. Now that the mesh has been cleaned up, let's check how it looks with smooth shading enabled. The boundaries become smooth and take on a rounded shape, while the overall form remains intact and displays without any issues. To sharpen edges while smooth shading is on, this can be done by subdividing the mesh. Switch to Multiars. Since I added the face group earlier, I enable Sharp Border and subdivide the mesh. A sharp border recognizes the face group and prevents smoothing the borders, allowing subdivision while preserving the original shape. For more details on sharp border, see the separate video. While checking the shape, subdivide is executed multiple times. Edges became sharp while recognizing the face group, and the overall surface also became smooth. Subdivisions can be undone, so adjust them as needed. Next, we'll demonstrate what happens when you apply Boolean to an object with adjusted topology. We'll proceed with smooth shading turned off. First, adjust the topology of only the left UV sphere to make the mesh finer. I will adjust the values. The mesh has become finer. Apply Boolean in the same way as we did before. Hide the left UV sphere. Select both UV spheres. Tap Boolean. You can see that the mesh with adjusted topology remains intact. Only the mesh of the areas that were overlapping has become finer, so you can confirm that it has become smoother than the outer surface. By adjusting the mesh beforehand, the state is preserved after applying Boolean, making work easier in various situations. Mesh adjustment here is the same as in method 01, so it is omitted this time. The third method uses Voxel Merge to perform a process similar to Boolean. The steps are the same as the method we introduced earlier up to a certain point. Hide the left UV sphere. Select both UV spheres. This time we won't use Boolean. Instead, we'll adjust resolution and use Voxel Merge. For reference, I set the resolution to 100. Enabling Keep Sharp Edges helps preserve edges to some extent. Tap Voxel Merge. The mesh is reconstructed with a shape change similar to Boolean. This is closer to resetting the entire mesh structure and rebuilding it, rather than simply cleaning the mesh. Therefore, the shape of the mesh changes overall. This function is especially useful in sculpting, as it is helpful when refining the overall shape all at once. It's worth keeping in mind. Since the mesh structure changes, using smooth shading will cause the shape to appear more distorted. If using smooth shading, it's a good idea to adjust the mesh as needed. Mesh adjustment is similar to method 01, but since the mesh state is significantly different, we will actually try it. Basically, we will proceed with the same steps as in method 01. Reset the gizmo to the object center with pivot set to auto. Set snap to 90 degrees and enable it. Move the pen along the green line to the right and rotate the object 90 degrees to the right. Reset the position to the world center with Move Origin. add a face group to the cut part. Since the values were adjusted earlier, you can proceed as long as the cut area is already shown in color. If the face group is divided into 3 or more parts, reset it and adjust the values again. The object already has separated face groups by default, so it's fine as is. Otherwise, lower the values to adjust. I will remesh with Quad Remesher. I will remesh with approximately the same number of vertices. Zooming in, you can see some mesh distortions. With smooth shading enabled, distortions become visible, so let's remesh again. Remesh again with the same button. Focus on the areas where the mesh is distorted. This time, with 2 remeshes, it worked well. However, depending on the mesh, object shape, and face group state, remeshing may fail. Especially as in this case with Voxel Merge, the mesh changes significantly from the original, so it may not remesh cleanly. In such cases, you can remesh multiple times as we did this time, or disabling face group and symmetry, and remeshing again may work. I often use this method, but depending on the situation, it may not always work. I hope you understand this. This time, we introduced 3 methods for cutting the overlapping parts of an object, using Boolean and Voxel Merge. Each method results in different finishes and mesh states, so please use them according to your needs. I particularly feel that the mesh state influences the ease of later work, so I hope you can use these differences as a reference. I hope this has been at least a little helpful.